Hello everyone, my name is Lin Chao. My project is to design a mobile CubeSat reception unit and antenna. My supervisor is Dr. Rad. On October 4th, 1957, the world's first artificial satellite, Sputnik 1, was successfully launched into the space. It was about the size of a basketball, weighed only 183 pounds, and took about 98 minutes to orbit the Earth on its elliptical path. In order to undertake more missions in different fields, the volume of the satellite becomes larger and larger, and the cost becomes higher and higher. However, a kind of microsatellite named CubeSat changed people's cognition of the CubeSat. It is a satellite with a volume of cube of 10 centimeters, weighs up to 1.33 kilograms. The CubeSat reference design was proposed in 1999 by professors Judy Peck Surrey of California Polytechnic State University and Bob Triggs of Stanford University. They firstly designed the CubeSat aimed to help their graduate students learn how to design, build, test, and operate a spacecraft. Small as the CubeSat it possesses all. The CubeSat can achieve almost all functions that the traditional satellites can, even it is small, and the cost of the project is far less than the traditional satellites. What's more, it can also save the space in the space. People say that the CubeSat will be a revolution of the outer space. The project is becoming so popular that a large number of universities and governments are dedicating to the study of the CubeSat. Satellite tracking and control station is an important part in the CubeSat project. Generally, a ground station for the CubeSat consists of hardware and software. A communication system between them should be built to transmit and receive data available. Antenna is used to receive the data and amplify the signal from the CubeSat. People use ground station to communicate with the spacecraft in the sky. When a spacecraft appears into the line of the station's sight, they can receive and transmit data from each other. Ground station for common satellite and ground station for CubeSat are similar but not the same. Here is the table that compares the 6 examples. Differences are present. 3 are common satellite ground station and 3 are CubeSat ground station. It gives a visualized comparison of hardware and software between the 6 different satellite ground stations. The hardware and software they use are commonly used in this field, such as the rotator Yaso G5500 with the dual controller and the Yaso GS232B interface. They can work well, but too cumbersome and outdated for this project, and they are difficult to connect to the computer or communicate with each other. Its rotators can hold a 2 meters antenna. Since the satellites began to be used to communicate and transmit information as an important part of the system, the ground station improved all the time to satisfy the needs of the satellites better. So more flexible hardware design and easy-to-use software are used in this field, especially for the CubeSat. These types of satellites are always for personal uses or education uses. Simple is better. So the Yaso G5500 rotators and the Yaso GS232B interface are not selected for this project. For the ground station, the most important hardware are the antenna, the rotator to control the antenna azimuths and evolution angles, computer interface to connect the rotator with the computers, and the PC to auto-tracking the CubeSat and control the rotator. The Yaji-Yuda antenna is a kind of directional antenna that was invented in 1926 by Shintaro Yuda of Tohoku Impro. The antenna has the advantages of high gain directly and a simple structure, so it is widely used in radio direction findings and long distance radio communication. There are two rotators installing and the two adapters that can control the azimuth angle and the evolution angle. Because of the design, the antenna can point the CubeSat and receive the strongest signals. Arduino is a kind of open source electronic platform which is intended for anyone to design his own electronic project. Different types of official Arduino boards are used as hardware. Arduino Mega 2560 is a kind of Arduino official board. It is a microcontroller board that can connect the computer with USB port and control the motor. So Mega 2560 can satisfy this project perfectly. The board comprises 54 digital input-output pins, with 15 of them can be used as PWM outputs. 4 UARTs are used as hardware serial ports. 6 analog inputs with a USB connection, the power jack, and a reset button. The board can be powered via the USB cable to connect with the computer, but only 5 voltage. To drive a servo motor with a higher voltage, the AC to DC adapter or battery can be used as the external power supply. Via the external power supply, a 7 to 12 voltage power can be supplied. And Dynamaxwell AX12A motor is a kind of servo motor with wonderful power to drive various mechanical components to run. It is smart with powerful functions. It has a daisy chainable system and an instruction status control system with packet protocol to transmit the torque of the motor, the real-time position and the temperature information. Because of the complete hardware and functions, the single-core network connection. This kind of motor is widely used in the field of robotics. Also, these advantages meet the request of this project. As shown in the figure, the servo motor has 3 wire network cables, 1 cable for transmitting data, 1 for voltage supply, and the other one is for the ground. The inner structure of the motor is a half-duplex UART, so it doesn't respond to the PWM signal, but uses instructions to read and write onto its memory with only 1 wire for sending and receiving. But because of its half-duplex UART design, it has difficulty to connect with an Arduino board. For the Arduino board and the half-duplex motor to connect with each other, a small circuit is required to make a conversion from the full duplex to the half-duplex. To meet the request, the Dynamaxwell AX Max driver board CDS55XX is used for this project. This board is a full duplex to half duplex converter to convert the TTL signal into the Dynamaxwell bus signal, so that this kind of servo motor is able to directly connect to the full duplex Arduino board. Also, every AX12 model has its own unique ID. So when the command is sent from the computer via the wire, all the servo motors will get the command, but because the command contains the destination servo motor ID, so only the destination motor will match and carry out the command. Here is the hardware connection. The AX12 Motor A connects with the Motor B via 3 jumper wires to make up a bus servers. Motor B connects with the bus driver board via the wires to one of the 2 ports. Here on the other side, an extra power supply or a battery is added on the board to meet the request of the 2 motor. To connect with the Arduino board, servers with TX to TX, X to X, and GND to GND connection between the Arduino board and the bus driver board. The last step is to connect the Mega 2560 board with the computer via the USB cable. For the software, the Arduino software is integrated development environment. It is a cross-platform application in Java language, and the software derives from the IDE for processing programming language and the varying projects. The software has a code editor with some great features, and it is capable of complying after uploading the program to the board. The communication between the software and the hardware is built, and the computer can control the devices connected on the board via the software. Processing is also the kind of open source programming language with IDE built for the electronic board. It is similar with Arduino software, but it provides a function that can control the board with the mouse. So for this project, without using the program to move the motor to the particular angle, users can also control the motor with using the software processing. Here is a flowchart about the software. The project CubeSat is an emerging field, but some parts are inextricably linked with other fields. So this thesis firstly gives some example about some common stylus ground stations and some CubeSat ground stations. After comparing their structure, hardware, and software, some choices of these respects are that relatively more popular and outstanding are made for this project. For this project, the main objective is to design an available CubeSat ground station module system with a small antenna. So the dynamic cell X12 motor and the Arduino Amiga 2560 board are compact and easy to use. What's more, they are programmed and easy to connect with the computer. After solving the communication and the power supply problems, the system works well, and the integral CubeSat ground station can achieve the functions the object requests. Here's a reference. And thank you for watching this.